and thank you for all those who are here joining us. I'm going to start talking a little bit about Toronto's greenhouse gas emissions and where we stand now in terms of GHG emissions in the City of Toronto. This is extracted from the Transport TO Net Zero Strategy, dated as of November 2021. City of Toronto constantly updates these documents, so there's always new targets. But just to give you an idea, right, in terms of greenhouse gas emissions, where we were in 1990 and where we are in 2019, right, in terms of total GHG in the City of Toronto, and transportation is the blue share here within those bars. Like, what's the first thing that comes to your mind when you see this? Any thoughts? Yeah.
Stricter emission standards for vehicles.
So we're not doing very well, right? This is not a very strong decay. It looks like, over the past few years, we're pretty stable, right? And so if you compare that with the City of Toronto's 2030 target of 65% reduction in greenhouse gas emissions compared to 1990 level, it means that in 8 years, we need to be here. A summation of the red and the blue and the green bars, right? That's a very, very aggressive target compared to the trend that we have already established, right? So this is not going to be easy. Now, I want to take a break and look at history, right? And what do we know that worked, right, throughout history in terms of, vehicle emissions? What do we know that works? And we always turn to the U.S. because the U.S. has much stringent emission regulations and emission standards. And we know, right, when it comes to controlling air pollution from transportation, well, regulation has done wonders, and we have to accept that, right? If you look at the 1970s, just, when the Clean Air Act in the US was put in motion, and look at the evolution over until today, we clearly see that there's been very big reductions in air pollution. And all of that is owing to stricter regulation. How does that work? US EPA sets new emission standards, said any new vehicle that is manufactured this year has to meet that much and that much and that much standard in terms of CO, NOx, PM10. And then the manufacturers have to go on and figure it out on their own, right? They have to figure out how to manufacture and how to improve their combustion technology on their own to start putting cars on the market that meet these guidelines. And the point is, and hopefully, as you will see moving to today, these regulations are going to become so much stringent, so strict, that it's just going to be impossible for internal combustion engines to meet them, and hence, manufacturers are pushed to start building electric vehicles. So regulation has done a great job, except that when it comes to fuel consumption, right, and it's only very recently that we started having, especially in the US, like fuel consumption policy and regulation, right? If you look at fuel consumption and you look at vehicles, manufacturers from 1975 to 2025, what is the first thing that strikes you in this graph?
More people are driving SUVs.
More people are driving bigger cars. So there's definitely a big rise in the popularity of larger vehicles within the vehicle fleet. Now, if you look at fuel consumption here, it's real world miles per gallon. Again, from 1975 to 2025. You look at, so now here, is an increasing trend, right? Because it's miles per gallon. It is not actually fuel per kilometer, right? You can clearly see how for the sedans we're at 31.7 mpg, but then for the SUVs we're at 28.4, right? Like, so we're building bigger vehicles. They're more efficient, but they're bigger now. So we're trading off that benefit of reduced fuel consumption by building vehicle, and then you can see the truck SUV, right? The actual truck SUVs are 23.8, right? So very big difference from the 31.7. So even if you think about, and my group does a lot of scenarios, I don't think we've ever done a scenario where, what if everybody's driving like a Nissan Micra? How much can we reduce just from like, smaller vehicles and lightweight vehicles. I'm going to go back to the City of Toronto's target of 65% reduction. I did a rough calculation, back of the envelope calculation, and based on the US EPA report, real world CO2 emission rates were 382 grams per mile in 1990 and 349 grams per mile in 2021. 65% reduction, we need to go down to 133.7 grams per mile. Okay? So clearly, just from internal combustion engines, we're not going to get there, right? It's going to be very hard at a fleet average, right? It's going to be really hard to get there just from building gasoline vehicles. Now, start talking about electric vehicles, right? EV mandates. They're going to help us close the gap, for sure. They're going to help us close the gap. We have examples of countries like Norway that are reaching like milestone, unbelievable penetration of electric vehicles. And Norway is like the crystal ball for all of us, right? Because we're so far behind, we can see what's happening in Norway. We can basically decide how we want to carve out policies to start electrifying vehicle fleet. Anecdotally, I say we had a positive zero panel discussion a couple of months ago, and we had someone from Norway talk about, their policy and how they managed to increase the amount of electric vehicles. And two things they mentioned was, first, they dropped the taxes completely on a new electric vehicle, right? And so if you want to buy an electric car, you don't pay tax. But the electric car is still more expensive than a combustion vehicle, right? But you don't pay tax. So there you go, if you have money, now it's cheaper to buy a car. Second of all, what they did is that road pricing, if you drive an electric vehicle, you don't pay a toll on the road. But if you drive a regular vehicle, you do. And what happened is that they actually saw an increase in vehicle in VMT for sure, and clearly a very regressive policy, right? Because then they're painting this picture of people who are wealthy and affluent, a society that is wealthy and affluent enough to afford all of this, as opposed to a big chunk of society that really just can't manage to do that. So I think there has to be, again, caution regarding how we deploy electric vehicles. Yeah.
I believe I read somewhere that Norway walked back the discounts on tolls.
Yeah. Yeah.
Because they were having too many electric vehicles and they wanted more people on transit.
Exactly. So again, once again, we go back to the same situation where just technology is not sufficient, right? Just promoting a certain vehicle technology, as long as it's still, an individual passenger car, we're still gonna incur the same mess, and roads are a key infrastructure, right? Somebody has to pay for roads. And so, if technology alone will not save us, then how do we get there, right? How do we get there? And today what I'm going to talk about three sort of different stories on decarbonization based on research that was done on within our group. I'm going to talk about just conversion to more efficient vehicles. We've tested hybrid vehicles, and I want to give you an idea of how they perform under real-world conditions. And I also want to talk about mode shift and VKT reduction. We're going to talk about vehicle sharing, but we're also going to talk about transit. And even though I haven't done any transit scenarios so far, this is going to be the big thing in our group for the next few years, is really just assess how much transit investment can help us achieve decarbonization. I'm going to give you some hints to really show you that it truly is, the key really is, it is transit at the end of the day. Now, but we clearly need to keep in mind, right, that the future of transportation, right, is more than just GHG reduction. And we all, and whenever you poll people, everyone has a very bold vision of what they expect their transportation system to do in the future, right? We want it to be affordable, shared, connected, accessible, integrated, equitable, all of these things. And the question is, and a lot of the questions that drive my research is, are all transportation innovations guaranteed to mitigate climate change and improve societal goals? Right? Or are there certain innovations that are just going to help us achieve deep greenhouse gas reductions, but could be, highly regressive, right, or highly inequitable? And so the first thing I want to talk about, the first story, is a story on travel behavior, residential location, and equity in the generation of greenhouse gas emissions from transportation. And this is primarily dominated by the work of An Wang, who was a former PhD student in my group. Then we're going to talk about the benefits of electric vehicles. It was led by Laura Minet, former student. She's a professor at the University of Victoria now. Then we're going to talk about automation and connectivity, the work of Marek that is sitting behind, and some some glimpses on some new work that Mark is doing on Uber and Lyft and vehicle for hire, but nothing in the slides. So let's start a little bit on travel behavior, residential location. What I really wanted out of this study is I wanted to understand, like, who's generating transportation greenhouse gas emissions the most? Where do these people live? What do they do in a day? You know, and so that we can better understand how we carve out policies to reduce their carbon footprint. So we took TTS data, and very often, most of you in this group are familiar with TTS data. It's basically travel diary survey. You call up people, you tell them, what did you do yesterday all day? Now, we don't necessarily call them, but pretty much that. And they give you all the trips that were conducted by the household. So we took every single household in the TTS, and we quantified their total greenhouse gas emissions from all the different modes that they've taken. If they're driven a car, we look at the distance, the time of day that they're driving, to look at congestion effect. If they took transit, my team has developed very accurate emission factors for all transit modes, whether you're on a TTC bus, whether you're on a subway, whether you are on a bus by another, you're on Viva, you're on any other transit operator, and looking also at the frequency of transit service. So we can get, you know, a good and accurate, you know, overview of emissions. And so this is not very, you know, news to you. In the GTHA, we still have 64% of people who drive, trips, you know, transit, auto passengers 13%, and everything else is distributed across all the other categories. So what this map shows you is we took the greenhouse gas emissions that are generated by every single household. We calculated them based on all the things that they do and all the modes that they use, and we brought them back to their home location, right? And so what this map really highlights is the amount of greenhouse gases in kilograms per person per day in every dissemination area in the GTA, right? With the warm colors, these are people emitting more than 5 kilograms, which is pretty high on average in a day, to less than 1.5 kilograms to very, very low. What is the first thing that strikes you in this map? Yes?
Yeah, the people in the rural areas have to drive.
Yeah, absolutely. So it confirms our intuitive hypothesis. It's not telling us anything we don't know, but it's nice to actually have numbers that confirm our intuitive hypotheses of, if you're living in the central areas, you have a very low carbon footprint. Well, what does that mean? Well, it also means a lot of important things for policy. It means that if we want to achieve deep reductions in greenhouse gas emissions, building a bike lane in the city of Toronto, which is really good, it's good for health, and it will enhance active transportation, and it is something we need to do, it's not going to help us achieve greenhouse gas emissions reduction. What we need to do, we need to think about the region, right? Because the biggest emitters are not in the city. Even if somebody lives in the city and drives in the city, this 5-kilometer drive, even if it's done in congestion, is not going to achieve deep reductions in greenhouse gas emission. It's uncomfortable. It really is uncomfortable to think like that, because then you already have to start thinking about, well, how do we reduce that biggest share? And then this means, you know, different kind of policy. If you look at the inequity in the distribution, so this is basically, this is a Gini coefficient, and for those of you who are unfamiliar with it, we're basically plotting the percent of population on the x-axis and the percent of total greenhouse gas emissions on the y-axis. And so basically this is telling you what proportion of population is emitting how much. What this really is telling you is that the top 30% of the population in the GTA is responsible for 70% of the emissions. Highly inequitable transportation system. The orange line is the one-to-one line. You have a really big area between the curve and the orange line, telling you that the system is highly inequitable. There's a very small portion of the population that is generating the big majority of emissions. And everyone else, 70% of the population is generating 30% of the emissions. If we start diving a little bit more into the different factors, the covariates, what is associated with emissions? Y-axis is median income and greenhouse gas emissions on the x-axis. There is a slightly increasing trend, okay? Affluence has a role to play. Affluence means something. Richer people do generate a higher GHG per person per day than more disadvantaged parts of the population, right? It makes sense. If you look at the emission intensity of travel, so this is plotting the mean emission factor per distance travel. Because if you look at the previous graph, you might tell me, yeah, but like somebody who's poorer, maybe they don't travel a lot of kilometers in a day. Somebody who's richer is traveling a lot of kilometers in a day. So if I normalize it on a per kilometer, grams per kilometer, and I look at median income, the trend still persists, and it's actually more exacerbated. So the transportation carbon intensity of someone whose income is greater than $125,000 a year is 312 grams for every kilometer. So that takes into account all the modes of transportation, the car that they own, all of these things. And for someone whose income is less than 15,000, it's 210 grams for every kilometer. It's 100 grams per kilometer difference, right, in your emission intensity. So again, that tells us something. If we look at greenhouse gas emissions as a function of accessibility, and for those of you who are not familiar with accessibility, is this notion, right, in transportation that gives us an idea of the opportunities that people can access under different modes of transportation where they live, right? So areas with high accessibility could be generally high density, highly walkable, highly bikeable, etc. If you're looking at, for example, transit or active transportation accessibility measures. And again, I mean, we know this. We know this. If you live in an area with high accessibility, your GHG intensity is lower, right? Because you have a higher access to transit, to walking and biking. If you live in an area with low accessibility, again going back to the idea of the suburbs and the rural area, well, you drive more and you have a higher emission intensity. Vehicle ownership does the same thing, irrespective of everything. If you have more cars, you emit more per person per day. If you're in a household that has more vehicles, that also tells us about what you do in a day. Now what I find is quite interesting, and I always like to show these maps side by side. This is a map that you've seen already, the map of greenhouse gas emissions, how much people generate. This is a map of air pollution in the city of Toronto. This is a map of traffic-related air pollution. It shows you the air pollution that is coming from traffic, from cars, from mostly cars and trucks, etc. And this is for black carbon, which is a specific pollutant, and I don't need to dwell more about that. What is the first thing that strikes you when you look at the comparison between the two maps? Yeah?
They're almost inverses of each other.
They're almost inverse of each other. It really means that the people who generate very little emissions live in areas where they are exposed to really poor, bad air, right? And the people who actually generate a lot of the emissions, well, they are dumping them in the central areas anyway, right? So they enjoy residences with good air quality, even though they are the ones that are generating emissions. Right? So it's like this additional level of inequity. When we think of inequity, we think of income and social disadvantage, but this additional level of inequity in transportation emissions that people who generate those emissions are actually not the ones who are exposed to them, right? They are the ones who are living in areas with good air quality. And so this is pretty much showing you the same trend in a box plot. What we're doing now is we're basically training deep learning models. We're taking aerial images of different neighborhoods, and we started doing that. We're taking aerial images of different neighborhoods, and then we're labeling that image with the GHG per person based on the analysis that we've done. And then we're training machine learning models to basically predict the GHG generated by people based on an image. Like, give me an aerial image of your neighborhood, and I'll tell you how much you emit. And it's obvious, because if you look at the images, the image already captures everything that we need to know about a neighborhood, whether it's dense, whether it's really sparse, whether there's a highway, whether there's a lot of density, a lot of activity, and it works. Like, the models are actually working, and it's a pretty nice way to sort of capture all of these relationships together. The next story that I'm going to talk to you about, and most of my students in here have heard this story many, many times, is just moving on to talk about the benefits of electric vehicles and of low emission technologies in a local context. And this is a study that continues to be in motion. We keep on pushing, we keep on adding, more elements. A lot of the work that we do in my research group is we take the TTS data, we take the trips that people do, we look at what people are doing throughout the day, and then we generate emissions models. We put them in the propagation models to calculate air quality, to calculate, all sorts of different indicators. And then we link them to exposure. The same people who are moving around are now exposed to this air pollution. And then we work very closely with epidemiologists to look at health impacts, right? And these health impacts can be in the form of premature mortality associated with air pollution, environmental stressors, respiratory incomes, various types of cancers, etc. So in this study, we looked at, we generated an emission inventory for the GTHA, and on a daily basis, the GTHA generates about 35,000 tons of CO2 equivalent. That's our best estimate. It's very much in line with the Toronto Atmospheric Fund, with the City of Toronto, but this is for the GTA. If you look at the contribution of the different modes of transportation, you've got 76% are from cars and SUVs, 21% are from trucks, like freight transportation, and only 3% from like public transit buses. And if these don't add up, because these are rounded, the little bits would be for the other things like rail and the subways. They're electric, but we consider the electricity generation and the issues associated with that. If you look at air pollution, traffic-related black carbon is basically soot. It's a marker for diesel exhaust. It's black. It's like a black particulate matter. If you look at black carbon, 71% are emitted by trucks, right? Like heavy-duty trucks. Cars and SUVs about 20%. If you look at NO2, nitrogen oxide, 50% is trucks, and the rest are distributed between transit buses and cars and SUVs. And why am I showing this? Because we are already now going to start to recognize there are certain trade-offs, right? If you really want to reduce greenhouse gas emissions, you just target passenger transportation. But if you really want to improve air pollution and improve health, you probably want to target those heavy-duty emitting, those heavy-duty diesel trucks, right? So again, the story is not that easy, right? It's not that easy to think about like what is the optimal set of policies that are going to achieve all of these things. So we took these emission inventory, like I showed you in the first graph, we ran them into emission models and air quality models and health models. And what these graphs are showing you is the health burden in premature mortality associated with the three different modes of transportation: private vehicles, commercial vehicles, and public transit buses. Air pollution's effect on health is numerous. You have, emergency hospital visits for asthma attacks. You can have, associations with, there's been proven associations with pulmonary cancer, breast cancer, prostate cancer. But premature mortality is one of the biggest, It doesn't mean that maybe everybody will die like 6 months sooner because of air pollution, but at a population level, these things really start to matter, right? And there are people with, other health vulnerabilities that make them more vulnerable, right, to the effect of air pollution. So if you look here at the impact of private vehicles, of passenger travel on early mortality, you clearly see, right? There's a big effect here in the central areas. We clearly see the highways. We're not drawing the highways here, not at all. This is just drawing premature mortality, and it really looks like, we see our highway system. If you look at the health effect of heavy-duty diesel vehicles, well, you get to see this big, huge hotspot right by the airport. And not because of the airport, because of all the freight movements that are going there. Peel Region they know that they have a problem with that, but we're able to demonstrate that we truly have, a high hotspot here. If you look at the burden of transit buses, like diesel buses, it's much smaller, but it's concentrated where we have, transit bus lines. I always worrying when I tell this story, because we don't want someone to look at it and say, oh yeah, diesel buses then are killing people. Because while they're emitting diesel fumes, of course, they have an effect, but the amount of cars that they're taking off the road is really big. And we're gonna see this later on as well in the impact of transit. If you look at the total in terms of premature deaths, you can clearly see that, freight vehicles are responsible for 407 premature deaths per year associated with their emissions. So then we started thinking, well, what are the climate and health benefits of renewing these fleets, right? So we have a base case where our cars are gasoline, our trucks are diesel, and our transit buses are diesel too. Then we said, well, what happens if cars and SUVs are electric? Everything else is the same. What if we electrify all transit buses, right? And what if we actually try and get cleaner trucks? We didn't assume heavy-duty truck electrification because we thought, people are going to say you're silly. You're assuming, long haul is electrified. But we said, what if all of our trucks are following 2008 emission standards and better? This is just to show you how old and poorly maintained the current heavy-duty stock of vehicle is in the GTA, that you're going to see that even if everyone is just have a model year 2008 and better, we're actually going to do really well. If you look at greenhouse gas emissions, we expected that. In the base case scenario, we have 35,000. If we electrify all passenger vehicles, we're achieving 70% reduction, which is good. Again, we're assuming the GHG associated with electricity production, but in Ontario, the emission intensity of our electricity grid is actually not that high, so it doesn't make a very big difference. And if you look at electrifying public transit buses or electrifying trucks, for greenhouse gas emissions, we don't achieve very big reduction. And that's something that I always caution, especially when I talk to transit agencies, is that you have to get out of this mindset of constantly thinking that if you're electrifying your buses, you're meeting climate commitments. They don't contribute that much, but the air pollution and mortality associated effect is really big. Use that as an angle to actually push for renewing fleets of buses and trucks as well. We've calculated these benefits, not just in terms of reductions in air pollution or improvement in health, but we monetize them. So with 100% electric vehicles, we've monetized that we're going to generate $204 billion per year in social benefits, okay? These social benefits are associated simply with just calculating a value of a statistical life, with the fact that people are not dying sooner anymore, right? People are living as their lifetime. With transit buses, we achieve $1.1 billion per year in social benefits, and it's going to be a lot easier to electrify transit buses than to start subsidizing passenger electric vehicles. And for trucks, we would achieve $2.1 billion per year. And if you look at the distribution of these social benefits across the region, again, you're clearly going to see the same as we've seen before. Heavy-duty trucks are going to have a very big benefit in Peel region. Electric vehicles are pretty much making everything better everywhere. Transit buses have a very local effect. And this is something that my group is pushing now. We're really looking at, because at a total, if you look at transit bus, you're saying, well, that's only 143 premature deaths prevented. But if you start looking around bus corridors, you're going to see really big benefits. And really big benefits in areas with highly low socioeconomic income populations, right? So if we add the equity element, this is a very important policy. We try to capture also the equity implications of these scenarios. And so what we did here is we plotted the benefits that you would achieve under the new truck scenario, or here, what is this? Oh, this is under the new truck scenario, basically, just to give you an idea. And so what we're trying to do here is we're looking at the benefits in terms of air quality of every policy, and we're plotting it across indicators of social disadvantage. Ontario has a report that is called the Ontario Marginalization Index. Anyone who wants to do equity-related research should refer to it. So Ontario has released different indices to capture social marginalization and social disadvantage. And these go beyond income, right? A lot of the time we think about income, and I always say, well, if you're a student and you live on your own, you have a low household income, so that's not capturing everything. So, and these indices capture, there's 4 different indices, one that captures material deprivation, which is kind of a weighted sum of income, of part-time versus full-time work, all sorts of things, whether you own or you rent your home. There's indicators for residential instability, etc. And these indicators are plotted at the level of the dissemination area. So when you're looking at the effect of anything, you look at VKT reduction, you look at whatever you want, try and map it and intersect it with one of your social disadvantage indices at a DA level. So you can actually see. What we really want to see here, in this case, is that a certain policy is going to achieve the highest improvement in the areas with the highest social disadvantage, right? These are sort of notions of justice versus equity. Like, do you prefer a policy that improves equally for everybody? Or do you think that there's value in pushing policies that will improve the most in areas with high socioeconomic disadvantage and high social disadvantage, right? And these are sort of the notions of justice or equity, and this kind of, again, adds another lens to how we evaluate policies. We looked at quantifying the social benefits in dollars for every electric car that we would subsidize and for every cleaner truck that we would be thinking about subsidizing. We're working on transit buses now because it's going to be quite interesting. It's hard to tell like the total fleet of transit buses and divide it, but we're working on that. What we found is for every electric car that is sold, that goes on the road, we expect about $10,000 of social benefits over the lifetime of the vehicle, okay? And these social benefits are associated with improvements in air quality, right? And so what does that mean for subsidies, right? If you compare that with subsidies, like the federal government in Canada gives a $5,000 subsidy for an electric vehicle. Ontario government used to give $10,000 before the current government, right? When we had a liberal government, used to give $10,000 right on. Right, you subsidize $10,000 and you're getting $10,000 in social benefits. These are social benefits, not money in anyone's pocket, right? But it's a social benefit. And when you are thinking and carving out policies, these are the kind of numbers that you want. For cleaner trucks, it's much bigger. It's about $300,000 in social benefit over the lifetime of a truck. But a new truck costs more than $300,000, right? Or maybe it's somewhere around that number. And I'm very interested, again, I don't have anything for transit buses, but I look forward to actually getting these numbers because I think it would really help the case for electrifying transit. All right, I have another 15 minutes, and maybe we'll take questions over time. The last story that I want to talk about today is just going over the performance of a hybrid electric vehicle in real-world conditions. I'm going to tell you why I want to tell you about this story. Because we're using like typical driving data from Toronto, and we are unveiling like interesting ways in which people drive in Toronto that actually make certain technologies not viable because of the way people drive. And so in this study, so a lot of the things that my group does is modeling, but also we do a lot of measurement. So we used, and this was a study that was led by Junshi, who's here. So we have something called a portable emissions monitoring system, a PEMS system. It's like a huge set of analyzers, and you instrument the vehicle with this system. You take a sample of the exhaust and you route it onto your gas analyzers, and you start measuring the second-by-second emissions of that vehicle as it's being driven under real-world driving conditions. And we had different driving routes, some that involved a lot of highway driving, and some that involved, more urban driving. And in this study, we tested a whole bunch of vehicles. We tested a lot of vehicles. We tested Nissan Rogue 2019, 2020, a Hyundai Tucson, so these are kind of like your very popular SUVs in Toronto, but we also tested the Ford Fusion, and that's our hybrid vehicle. And so, if you look at the fuel rate, the amount of fuel that is consumed by those different vehicles, and what I really wanted only to focus on is how the green bar compares with the rest of the blue and the orange bars. The blue and the orange bar refer to our conventional vehicles. They're GDI, gasoline direct injection, and I'm not going to go details into that. It's a new combustion technology, relatively new, and your hybrid vehicles in green, right? What we started noticing that, yeah, if you're idling, the electric motor is on, so green is 0, you're not emitting anything. If you're cruising, right, your hybrid vehicle is giving you benefits because the emissions are low. But if you're accelerating, the hybrid vehicle is doing worse than or almost just as well as the other vehicles. You're not seeing as many improvements anymore. And then we looked at the emission reduction that you get from this hybrid vehicle compared to our conventional vehicles under different road types, right? And we clearly see, right, on local roads, you can get maybe a 40% reduction, but on expressways and expressway ramps, you're almost around 0, right? This is for fuel consumption or CO2, and for nitrogen oxides, it's even more exacerbated for air pollution, right? And so context really matters. Just driving a hybrid vehicle doesn't mean that you're doing something good, right? It matters where you drive it and how you drive it. We had a collaboration with folks in Beijing, and they had collected a bunch of GPS data from drivers in Beijing. We had done a very similar study that Junshi had led, where we gave drivers GPS units. They put them in their car for a whole week, and we get information on how people are driving over that entire week, right? And similar thing had happened in Beijing. And so we said, now that we have real driving patterns in the two cities, let's compare how a hybrid vehicle would do under these contexts. Do we get actually better emission reductions in Toronto than in Beijing if you're driving a hybrid vehicle, or the other way around? And the results are actually quite interesting, because you clearly see here the percentage emission reduction. This is the y-axis. So a higher emission reduction means a higher benefit for your hybrid vehicle, right? So you want your boxes to be high. Beijing is in red and Toronto is in blue. For CO2, you actually see close to 40% reduction if you're driving that same hybrid vehicle in Beijing versus you get 20% in Toronto. For CO, it's almost the same. For nitrogen oxides, again, the benefits in Beijing are a little bit higher. And we started thinking, why? Why do we actually see, why these things are working better in Beijing? And then we started comparing the GPS data. And if you look at the rates of acceleration and the rates of deceleration, the aggressiveness in acceleration and deceleration in those two contexts, so if you look at and focus mostly on acceleration, which is in blue, we actually see higher acceleration rates in Toronto than we do in Beijing. VSP stands for Vehicle Specific Power. It's an indicator of the power that you use when you move a vehicle under all sorts of things. And you can compare these things, and you can clearly see, even though the medians are not so different, we actually have much higher power modes in the Toronto context. People are accelerating more aggressively, and they're driving under much higher power regimes. Then we started diving into speed limit violations, right? We're not allowed to go back to the people and tell them what they're doing, but then we mapped the speed limit on every single road.
Secretly let the police know that you're speeding, and then they're gonna knock on the door.
And so we started mapping the proportion of drivers in Toronto that exceed the speed limit by any amount, more than 0, any amount, almost 85% of our sample at some point are driving over the speed limit. There is absolutely very few that are always at the speed limit. Exceeding speed limits by 10 kilometers per hour, we're still around 70%. right? And this includes all kinds of roads. The roads where, you normally maybe don't get penalized, it's not just the highways, but almost everyone. If we go down to 20, more than 20, we are at around like 50%. If you look at the Beijing data, it's so much lower. And I was perplexed, and I have a lot of students from China. I was like, why? That's not what I hear about people in Beijing, that they're very, very diligent drivers. But because there is so much policy, right, Junshi, on speed limits. There are speed detectors almost everywhere, and you get fined, yeah?
I'll tell you a story. We lived in Australia for a while,
Yeah.
and there was a bridge we would take sometimes to go into the city of Brisbane. And there was on the off-ramp off this highway bridge, there was a speed camera. And a number of times my family got dinged by that machine.
Right.
It's amazing.
Yeah.
It would be like putting a speed camera on the off-ramp of the QEW or something.
Right. Yeah.
And
Oh,
the
yeah.
amount of people you would
Yeah.
rake in.
Yeah, absolutely. Yeah.
And that's just standard all across Australia.
Yeah, absolutely. I mean, in Toronto, we definitely don't have enough. Definitely don't. And then we compared again the percentage of the trip travel time spent above the speed limit, right? And again, in Toronto, we are somewhere between 20 maybe and 7-8% of the time when you're above the speed limit. In Beijing, it's a lot lower. It is really just regulation, right? It is really just regulation. The reason why I say this is because all of what I'm trying to say is that context matters, right? It's not just about rolling new technologies. The local context really influences how these technologies are going to work and how they are going to perform. So it really is important, right, to address behavior planning, transport networks, to maximize the benefits of new technologies. What we also find in the hybrid story and in the speed violation story is actually people who violated speed limits emitted more because of this aggressive driving, right? Because, and that's one thing, I explained that to the City of Toronto one day. We're talking about, speed limits, and I said, reducing speed limits, anecdotally, people think that if you basically make speed limits more stringent, more strict, cars are driving slower, so they emit more. Because people intuitively always think, if you're driving slower, you emit more. What speed limits do, if you have a really high speed limit, it's a ticket, it's a visa for you to accelerate as high as the speed limit, only to find yourself decelerating very soon. Why? Because we live in a very congested network, right? It's not like cars are cruising all over the GTA. We're in congestion most of the time. So what we end up having is really these very aggressive accelerations and then sharp braking and then idling, and then it happens all over again. If you actually make the speed limit more stringent, more strict, you could enable more smoother driving, right? And smoother driving does reduce emission, helps reduce emission. So these are the things. So people who violate the speed limit arrived home to their destination on average 2 to 3 minutes earlier. That's really the average, it's not that great. But their emissions were 30 to 40% higher, right? Out of this driving. And it's important. I think this kind of contextual evidence is really important to help us carve out policies. I only have 5 minutes left. I'm going to jump to the conclusion. I'm going to skip all of Mark's amazing analysis on vehicle automation and sharing. But I do want to stop here, and I'll give you a hint of what Mark is doing. And I'll get your question. Yeah, go ahead.
The 2 to 3 minutes faster, is that per
Over the entire trip. Yeah, over the entire trip.
Does that consider how long the trip is?
Yes. Yeah. So we can calculate the percentage. I don't have it off the top of my head. I just had it in minutes because I thought it was impactful. 2 to 3 minutes, even for a 10-minute drive, is not a lot, right? So I think that absolute value really matters. This is a combination of work that my team has done over many years, and I wanted to just put it in sort of a visual way to show the impact of transportation choices and investments that we made. This on the x-axis is the emission intensity in grams of CO2 equivalent per passenger kilometers traveled, right, per PKT. And this is real, hardcore data collected and modeled for all the GTA. If you're driving your own personal vehicle, gasoline car or SUV, your median is somewhere around 280 grams per passenger kilometers traveled per passenger. But you can go as high as, 330 and maybe as low as 230. You're somewhere around here, okay? If you take a transit bus, right, even your good old diesel bus, your median intensity is only 50. Now it ranges. And why does it range? Because of occupancy, right? I mean, if you have, again, I always give the example of your good old transit bus, going up and down Kipling Avenue at nighttime. Yeah, for sure. The bus emits about 2,500 grams for every kilometer. If you have less than 10 people on the bus, you're going to be more than the 250 here that we're looking at, right? So there are going to be times about where the bus emissions are, but the median is around 50. If you take a GO train, again, there's variability because of ridership, but then we're talking at a median that is somewhere around 30. If you're riding the streetcar or the subway, it's very, very low. If you're driving an electric car, it is somewhere around 22. The one number I don't show you here is that if you look at the average of all transit, the buses, the streetcar, the subway, and the GO train, you normalize it per passenger kilometers traveled, the average over the entire GTA, you arrive at 18.7 grams per passenger kilometers traveled. You arrive somewhere very low here. Currently driving an electric vehicle in Toronto, maybe 15, 16 grams, we're right there. Like transit is really right there, very competitive. So only think about how well you could do if you electrify maybe those two modes of transportation. It will be so much better, right, than subsidizing electric vehicles, even with the current fuel makeup of our transit systems. And I'm going to end here by basically saying that, I hope that at least I've shed light on the fact that the solution to transport decarbonization is really multifaceted, right? We want to promote electrification. Yes, we do, for sure. There's no decarbonization without electrification. But we also want to make sure that it's not electrification only for cars, maybe for bicycles, maybe for other modes of transportation. It's equitable electrification, it's affordable electrification. We also want to think about freight systems, right? And how we actually solve and decarbonize our freight systems. We want to build multimodal transportation hubs. We want to make it easy for people to move around using transit. We want to try and convert our road space from something like this to something maybe like that. And we want solutions that are not just sensitive to a North American context. It's important for us to also think about solutions that are sensitive in a global context as well. And we want to do all of that while making sure that our solutions are equitable and socially just. So I hope you agree that the solution to transport decarbonization is not just multifaceted, it's really highly complex, right? And when people say, well, we know what the answer is. Like, the answer is easy. No, it's not easy. Because it's about what do we prioritize first and how do we actually prioritize our investments. And I think with this, I end my talk, and thank you for listening.